Pizza and ice cream is okay?
Delicious.
So, we're going to continue on here. We are in Chapter 1, Section 2. Just a reminder, we're going to finish Chapter 1, and then we're going to talk about salmon for a couple weeks and start testing all that stuff as we get rolling better with surveys and all that stuff. Okay. I'm sure we talked about this at some point. When we think about the scientific method, how does it start? Like, we didn't list out steps or anything like that. Do you guys recall in any of your courses, how does science start? It starts with a hypothesis?
With a question.
It starts with a question. Always?
Observation.
Yeah. Okay. So this can be misleading because oftentimes you learn question or statement, right? State a problem, develop a hypothesis, or do your research, then develop a hypothesis. But that totally misrepresents everything. Have you guys ever wondered about something that you don't even know you have a wonder about? And does that question make sense? Have you ever, give me something you're interested in learning scientifically that we could approach scientifically. I don't care if it's fish related or not. Space. Okay. Have you heard of space and seen space before?
No.
Are you sure you've never seen space?
Yes.
What's between you and I? Okay. So, but no, you're right. Have you ever seen a star? That's probably kind of what made you interested in space. If you had never seen a star or the moon or the sun, you think you'd really have a whole lot of curiosity about space? Probably not, right? It wouldn't make sense to wonder about something that you've never seen or thought of or heard of or anything like that. So you've been lied to. You have to observe something first to develop something that interests you and a question or a problem that we're trying to solve. You had a comment possibly.
It just reminded me of how it's impossible to imagine a new color.
Is it?
Yes.
Why?
Because you can't imagine a new color because you've already. It's just like what you were saying.
I agree with you. Yeah, I'm just trying to be the devil's advocate here. You want to hear something crazy?
What?
Blind people can't see, right? If you have somebody who's born blind, they can feel a cube, they'd be able to identify a cube by feel. You guys probably can as well. If somebody's been blind their whole life, they've never seen a cube, but they felt them, how good at making a cube or identifying a cube are they if their vision's restored? You think they could do it? Terrible, turns out. Because it's two totally different lines of thought and physical processes. One more fun fact about it. Blind people dream. How? Do they dream in image or do they dream in sound? Bless you. Both, it turns out. Very different, you can't explain it because, I don't know why I'm stuck on blind stuff right now. Blind people, they don't just see black. It's not like you can close your eyes and say, oh, that's what it's like to be blind. Do you guys remember seeing stuff before you were born? That's what blind people see. They just don't get to see anything. They don't have the concept of light and dark. It's just nothing. That's like the absence of vision. Weird ideas. All right. So we're going to not just distract myself. And we're going to talk about, after we have this induction and deduction worked out, we get to start thinking about how does one go about testing ideas. Okay. Testing ideas. Now, once we have an observation and maybe we've done a little bit of collection even before a formal experiment, like we pick the fish out to see if they all have gills or not. What is really important about this is hypothesis. You guys have heard the word. How have you been taught, or what's your understanding of a hypothesis? What is your understanding of a hypothesis? How would you explain it?
None of it.
How many of you have heard educated guess? I bet all of you have. That language is a lie. That's not true. Guessing indicates that there's no real logic or reason to it. It's a guess. Now, the educated part might make that maybe passable, but here's what we're going to agree on. When we have some observation that makes us wonder about anything, we get to use these powerful logical tools of induction and deduction, and we're going to state the following. Induction and deduction, and you can just write logic because these are the logics that we're talking about. Induction and deduction. It leads to conclusions. Now, there's a big part of this. The conclusions that you get purely from inductive reasoning and small observations and things like that, it leads to conclusions that might be true. Now, and I'm going to say could rather than might, so it doesn't sound like a guess. You have some sort of logical reason to have a belief about something or how it works or whatever the case might be. Now, this conclusion that you come to based on inductive or deductive reasoning has a name. And it's much better than just saying you're guessing wildly in the dark, because that's not what really happens. This fancy logical conclusion that you haven't formally tested yet, it's called a what? This is your hypothesis. Okay. Now, anytime that I write all caps like this, I will, it'll be very clear. I hate it. Will somebody flip the clear switch for me? More than an educated guess. Now, how many times do you have to test your hypothesis? Dwayne, will you flip the clear switch there on the wall? Yep. Other down. I'm messing with you. You can just close it down. Okay. All right. Is it guaranteed to be true? No, it's a hypothesis, but we have a reason to believe it. Can we test it once and be done with it? No, you got to do it over and over and over. Now, when you're writing a hypothesis, and we're just going to keep expanding on this, and I'm going to try to be not crazy righty today. That's not a real verb, but I think you guys know what I mean. We're going to construct our hypotheses, and we're going to think about how does this actually work. Construct. And I'm going to use hype for a shorthand, so we don't have to write as much. Okay. I want you guys, let's stick with space for now. We'll come back to the marine side of stuff. Anybody interested in space, or you think space is pretty, or any part of it at all kind of interesting? Okay. I want you guys, let's see here. I want you to create a hypothesis about how our solar system moves. Not how we move in our solar system, but how our solar system moves. Because you may or may not know. What orbits around us?
What orbits around us?
Yeah, the moon, okay? What do we orbit around? There's a natural question there. We see those things. We're building a logical thought. Hypothesize about what dictates the movement of our entire solar system. Not our planet, the entire solar system. Come up with a good, quote unquote, good hypothesis that we could possibly use a scientific method to check, and try to come up with one that you absolutely no way you couldn't check it. This is going to seem rough. You can turn around and make larger groups if you want. Hypothesize, how does the solar system move? Not the Earth, not the moon. How does our whole solar system move? Good hypothesis that we can maybe check, and a bad one. If we're trying to make a hypothesis here about what we do, the good hypothesis, I think, is good to come up with. Some of you may know the answer. Some of you might not, and that's okay. Let's just see if we can pick out the logic here. Anybody have a good hypothesis about how our solar system moves? You may know it as truth, but whether or not it's really truth or not is a kind of nebulous area. Give me a reason to why or how it might work. We have the moon orbit around us, right? And then we orbit around something bigger, which I've seen now 2 examples of this happening. Through induction or deduction, can we make a logical step here? Our solar system probably orbits something else. Anybody come up with that idea? Okay, now it turns out there's a whole lot of crazy stuff. Is that logically sound? Does that work inductively to say it happened once, not twice, but thrice is really what it happens? And it happens to all the other planets and everything else. It is a reasonable hypothesis. Now, that's a pretty good hypothesis, and I'll tell you it's true. But that question always just adds to another one. If we orbit around something in our galaxy, what's the next bigger question? Yeah, what moves our galaxy? And that's even a bigger question. And there are hypotheses and theories that regard those things. But that hypothesis that we listed, that first one, that we must revolve around something, it's good. Now, the reason it's good is because we can keep track of ourselves in space over time. Now, modern technology allows us to do that. You guys have probably seen all the cool videos where they show the stars and it keeps the Earth and you see the whole stars move. Much cooler if you shift the perspective and keep the stars in place and watch the planet rotate, because it changes your point of view and you see how it works. Going through that, the most important thing when you're making a hypothesis, you have to be able to do what? So check this out. The hypothesis that we orbit around something larger in the center of our galaxy is pretty cool. What about the idea that my brother-in-law actually spins this little motor that spins it? Can you ever verify if that's true or not? Why? It's not testable, right? So when we're looking at these, have to have the potential to be tested. And we don't prove hypotheses. We do what? We do test them. What if the evidence says, yeah, seemingly this is what happens? We don't have proof with it because that will exist over and over and over throughout time. We never prove in science. We support. Now, the bigger part of this is, one, it's awesome. If you have a hypothesis that's tested and you found evidence in support of it, that's a pretty good indication that you're on the right track. Nothing about truth stated there. You may be closer to the truth, depending on what truth really means to you, but you have to be able to test it. The holy grail in science isn't proving new hypotheses and stuff. It's disproving things that have been accepted as true for a long, long time. That is a much larger and more meaningful discovery in the world of science. Now, I want to stress this. Can we prove a hypothesis? No! Check it. Can you prove a hypothesis? No, you can do, well, somebody said yes. You can't prove it. What do you do with a hypothesis? You support it, because proof in science, remember it's cyclical. 500 years ago, like Isaac Newton had a pretty good idea of why the planets moved, and it was supported by a bunch of evidence. Turns out he wasn't exactly right. We had to tweak things a little bit. He was proven true for 500 years, but obviously not if it was ever disproven. How would you disprove something that's been proven? Doesn't even make sense. Okay, you have to be able to support it. Now, I want to make that other statement just so we don't forget it. We do not prove in science. There are only two disciplines in which truth exists. And I would say really there's only one. You guys have probably done a bunch of it. You've seen like verified, supported truth. What course did you see truth in? Let me rephrase that. What class did you prove things in? Geometry was the right answer. But yeah, it was math class. Okay. Now, as we go through here, we accept it until evidence stops supporting it. That's how things work. Awesome. Do you want to actually talk about the truth to our hypothetical thing? About the space? Okay. We don't prove in science, we support. Now, beyond this, your job as scientists, no matter whether it's your hypothesis or somebody else's, once we have a hypothesis, what do? You want to support it. How do you gain support or lack thereof? You test these things. So it is your job in here and all of our jobs, testing a hypothesis. You have one major job. I don't know if you guys have seen this. I thought about changing the quote, but I got lazy. Never stop questioning stuff. Like, that's just an important idea in life. I hope you all realize that I'm excited about learning, and I hope that you never lose the excitement for learning. Whether or not you're excited about this in particular is, I hope so, but maybe not. When you test a hypothesis, your main job is to be a skeptic. You are encouraged, and you should be skeptical of anything that you hear somebody presenting as truth. It's easier to say than it is to do. More work, way more work is done in showing that somebody's wrong than they're right, because if you can show something that we accept as true, for now at least, if you can show they're wrong, you are like super good. I don't know the right word for that. All right. Now, is it possible that you and I have the same question, first of all? We see the same thing, and we have the same wonder. We're trying to solve the same idea. And we collect evidence, and we collect the same evidence. Is it possible that you and I reach different conclusions and different hypotheses, and we, like, from the same data, can we interject our own bias into it? What's bias?
Your own beliefs.
Yeah, your own beliefs and opinions and all that. So as we're looking at here, you're supposed to be skeptical, but when you're developing and testing these things, we want to also have and welcome alternative hypotheses. Okay. There are a lot of controversial things, none of which we're going to talk like at length about in here. But there's a lot of things where two or more people have alternate ideas for why something happens. Hopefully you get more than just two. The more you have, the better. Because if we have 100 possible explanations for something and I'm able to disprove 99 of them, that last one is starting to look what? Good or bad? 99 or 100 explanations. We've shown 99 of them are wrong, but we can't disprove that last one. Is it looking better or worse? Oh my gosh, it's looking better if we can disprove everything else. All this does is help us out. Okay. Oftentimes, just worth mentioning, technology and science obviously go hand in hand. We're going to take a brain break after this because I can already tell it's starting to drag on a little bit. Cool. Does science or tech come first? Always? I'll tell you, it really varies. There's times when the tech comes first and science get developed after it, and vice versa. Einstein knew a lot of his ideas before we had the capability to actually check them. Now we can check them. We're testing stuff at CERN, the big particle collider in Switzerland, that was developed in like the 20s and 30s. So we're confirming those ideas from 100 years ago. All right. So thank you for that. Hopefully that got the blood pumping a little bit as we go through. We'll see how it works out here. Okay. We can make observations to test a hypothesis. That's really common in the way of like biological sciences. You don't want to do an experiment because a lot of the times it's not ethical for you to change the things that you might need to change. If you're trying to study how does ocean acidification impact the Great Barrier Reef, you could take thousands of gallons of acid and pour it on the Great Barrier Reef and you would have your answer. Should we pour thousands of gallons of acid on the Great Barrier Reef though? Obviously not, because ethically it's not the right thing to do. Now, as we get rolling through, we do, however, especially in our class, we are going to have the ability to start running through some experiments. Now, it is my hope, and I'll tell you, it's my promise at any time that we do experiments in here, we will follow certain ethical and moral guidelines that is just kind of agreed on in science. If you open up the corpse of a dead organism to look at how it works, what are you doing? What's that called? So maybe after it's died, you might call it an autopsy. But like if we were to go over to the lab and we had like a fish that we cut open to look and see like how its actual internal structure was, we're not doing an autopsy and doing an investigation. What are we doing?
Dissection.
A dissection. Are dissections ethical? Is it okay to do a dissection? Yes. Okay. A little bit of dark stuff. What if the animal were dead? Would that be okay? No. Does that have a name?
What? Oh, yeah.
If you complete a dissection on a live animal, is that okay? No, it's awful. It's unethical. It's called vivisection. It is against the law, against every code of ethics that you'll ever look at, with small exceptions when developing medical treatments with animals that have been developed for that purpose. Okay, so big elephant in the room. What's different? And did you finally notice?
Yes, these guys switch seats.
Yep. If
Oh, really? That's it.
we're gonna work on smirking and looking at the person. Yes, you guys can stay where you want, or we can move back real quick.
I'm moving back.
Yep. So yours was a little bit different because you had somebody different sitting next to you. Grace hooked it up. It took. Cool. All right.
Notice when I came in.
So interesting.
Because like me too.
I wouldn't notice, not at all. All right. So when we go through this, an experiment, we are manipulating an environment to gain knowledge. Now, we will go through the nitty-gritty stuff about variables and all that. Manipulation of environment in whatever sense that we're looking at is what we're really thinking at. We manipulate it somehow, and that's what our goal is. But to do it to test a hypothesis in a way that's ethical and is okay in the world of science and just moral as well. Now, for this, instead of just going through like a bunch of different things, love the way that your book does it, and we're going to take a similar route with it. We're going to think about an observation that, like a real observation. We're not going to go through all the hardcore scientific data, but we're going to play the scientific method with this thought experiment. Okay, do we eat shellfish, or I guess oysters and mussels here? This is deja vu-y. Did we talk about this the other day? Okay, why don't we go out and pick mussels here typically?
Sometimes it's like a disease, not a disease, but like a.
So yeah, you're going to get PSP, right? From algal blooms that happen, and they happen all over the state. You can eat mussels from here, just so you know, you can, but you should test them, because if you have PSP, you'll live through it so long as you have somebody or some machine that breathes for you for the next 6 to 12 hours. I don't know that we have a whole lot of intubation machines on this island, and I don't know that you're going to find somebody to squeeze a bag for 12 hours to keep you alive. Okay, second part, for real you would. Obviously, if somebody had paralytic shellfish poisoning here on the island, somebody would breathe for you if you had to. But it's easier to just avoid it. Weird little side turn there. So here's our thought experiment. We are going to work with the following observation, and we're going to run through a few parts to kind of lay this in. So we have an observation right off the bat. And this is a real observation that's happened. There's a lot of different types of mussels. There's obviously different types of fish and fishes that we will deal with. But however, here's our observation. We start with the following. Mussels, like the mollusks, mussels in Alaska are larger than their Californian counterparts. And that should be capital. Okay, same species, but we're in Alaska and they're in California. Now, this is a statement that somebody observed after collecting all the data. They didn't just pick one and one, because if you pick a super mature and a baby, then it's not going to work, right? So this observation has been made. We have that. Why? Like, based on what you know right now about California and Alaska, why do you think this might be true? We're going to see if we can agree on a single thing. Is it possible? We all have different explanations right now, though. Awesome. We should. That's how science works. But I'll help you narrow it down, but I want to hear some of your ideas. Why do you think that mussels in Alaska might be larger than the same species found in California? I'm going to give you a minute. Talk with your nearest people. It doesn't have to be just your group. Come up with a hypothesis. And I want to hear a few of them, and then we'll work with a single hypothesis that we'll work through to finish this. Do we have different weather? Yes. Where's the water going to be warmer, in California or here? Is it possible that the temperature of the water has an impact on it? Okay, all like that aside, is everything else the same between us? Between the mussels here and there? Just the weather is the only thing that's different. I liked your guys because your group said it. What was your thought that something different other than just the weather and temperature? Pollution. Do we do a lot of polluting along the coast in Alaska? Okay, so let me rephrase that. Do we do a lot compared to California? No, there's like, I don't know, 30 or 50 million people in California. Most of them live along the coastline. Not all of them, but most of them. There's way more people, way more pollution is going to happen in that water, for sure. Now, our ocean's better was another one I heard. Don't love that statement, but on how, depending on how you think about it, maybe. What do you think we might have more of in our water than they do off the coast of California? Less pollution, hopefully. More what? More nutrition stuff, and specifically that was you spoke to as well, right? Maybe the ocean currents happen to bring up better, more nutrient-rich water here. Now, is it possible that literally, is there a group that I didn't call on? I don't remember yours.
Ours?
Did I remember yours? Yeah. I don't remember what it was, but if I said it, I'm cool with that. Did I get you guys?
It was just like this.
The weather. So same with temperature. Maybe the storms are bigger or smaller. Okay. Is it possible that literally every single one of you is correct? Is it possible that nobody's right? Okay. So with that, I agree. Now, I'll tell you, it happens this way a lot of the time because it's not only mussels. If we observe that other animals happen to be larger here, like we get sea lions here. Stellar sea lions used to be really abundant in this part of the world, but not as much. I don't even know if they exist anymore. Do stellar sea lions still exist? They're endangered if they do still exist, because they were almost hunted to extinction. Okay, can we all agree that without measuring the pollution and stuff, water's definitely colder? Could that be the cause? Like, we could list any of them. Let's go with that one. Hypothesis, colder waters make larger mussels. Okay. Now, we will set up and we'll keep rolling with this. Probably tomorrow we'll finish. If the weather's super nice, we might go out and do a survey just because I don't know. But I don't know that it's supposed to be super nice. Why would colder waters make stuff bigger? let's say hypothetically, colder is like subjective, right? Because what's cold for me might not be cold for you, and vice versa. Do we all sweat in here? We do sweat. Like, we might all sweat differently, but like if we blasted in as like 110 Fahrenheit in here, would we all start sweating? Does it take energy to produce sweat? Your body has to do something, right? Now, if I'm using all this energy to try to cool myself down, which is what sweating does, we compare it to you in a 70-degree room where you don't have to sweat and you don't have to shiver to make yourself warm, like you're just nice, comfortable temperature. Which one has more energy to commit to getting big compared to just staying warm and staying temperature controlled? Colder environment would work better for you because you're not having to sweat. Maybe that could be something with this. Now, in reality, you guys all give me a ton of stuff. All those different impacting factors that you've listed are just examples of things that we could conceivably manipulate in a given situation, right? What are those things that we talk about in science and throughout the course of an experiment that we might get to manipulate and change to see changing this influences it this way and so forth and so on? Starts with a V and ends with variables. All my variables. Okay, so what we'll do is I'm going to write this very last thing. I'm just going to make the comment that for this situation, that hypothesis, it's a good hypothesis, but there are too many variables right now. We cannot control variables in nature, especially if we want to be super ethical. We can't control all of them at the same time. It's not like we can go dump a bunch of pollution in the water and see if it really does impact it the way we think it does. So to be able to run this and deal with these variables, what do we need to do? And how will we decide if our hypothesis that colder water is indeed the culprit? Keep that burning question in the back of your mind. We'll start there tomorrow.